In Lisbon, Portugal, highly advanced ICT mobile apps have been co-developed with the campus users and are giving control of the indoor environment to the community, increasing comfort and reducing energy waste.
The Smart Campus project sets a highly ambitious goal of developing a new generation of intelligent energy management systems aimed at managing energy consumption in a much more efficient way in a university campus through a stronger interaction with end users and also with a learning capability of user preferences and habits as a way to achieve a more energy efficient management of the campus itself. This will be made possible through the deployment of web and mobile apps that will allow these end users to interact with the campus and effectively change the way the building consumes or uses energy, being more energy efficient.
And here we are having a set of different experiments to test intelligent control of energy management systems. Well, we are basically having 4 different setups. The first is a library where we are testing purely automatic control of lighting and HVAC systems. The idea is to take on one hand more advantage of the natural light conditions and controlling individually the different luminaries across the library. And in terms of the HVAC systems, we are measuring what the external temperature, the interior conditions, humidity and temperature, and then we are implementing a set of strategy control for different zones in the library depending on the occupation.
About the changes I noticed in the campus, I realized that the light system has changed. For example, here in the library, the lights are now less time turned on with different intensities through the day. And I think that is great because we have a lot of exterior light and then we can save more energy.
Lighting systems now make full use of natural light and encourage students to seek the best places to study, and in the auditorium you can decide if you are at the right temperature for those demanding lectures.
About the new installation in Amphitheater 4, the professor has now the ability to change between different lighting, HVAC and projection scenarios. A few months ago, I tried a mock-up application where I could express my opinion about this new system.
They have available application on their mobile phones where they can vote on the actual conditions in terms of lighting and temperature, and then the system will take the different votes from the different students, and with an intelligent algorithm will decide which is the optimization point that satisfies more students.
Throughout the development of this process, we adopted a strong co-creation process within the end users as a way to capture important information on the design phase, on what kind of functionalities should be deployed in the campus, as a way to make sure that we were following the right design and the development path.
User involvement is the key to achieve sustainable solutions and long-term behavior change. By implementing living lab methodologies and designing thinking approach, users are at the center of the innovation process, co-designing and co-creating the services with the developers and SMEs at all stages of the project.
The third case study is the Nucleus 14, so basically it's a set of 12 offices where we have individual control of lighting and HVAC system again, but here we are running an intelligent algorithm that for each space is learning the comfort parameters of each user. So basically this algorithm has a learning phase where he's observing for which temperatures and which light conditions do the user decides to turn on the light or turn on the air conditioning, and then after this learning phase he will automatically control the conditions based upon the user's preference, but also taking into consideration the external temperature, the external light conditions, and also the energy efficiency measures that the energy manager of the campus decides. So the fourth experiment is the computer lab. So basically it's a small room that students use to take labs on computer science and also as a study room. And there we will have also the control of scenarios. So there will be a set of pre-prepared scenarios for lighting and HVAC system control, but also some interaction with the students through web applications where they can also interact with the system and decide upon which is the best conditions to be studying or to be in the class in that room.
In order to engage users in the Smart Campus project, IST promoted several training sessions and workshops in order to develop programming skills in the students, to better interact with the building and promote a more energy efficient behavior of the students.
We also have another experiment which is slightly different, which is the Energy Lab. So the Energy Lab is a small lab where we are developing all these algorithms, and this laboratory is fully supplied by a container with renewable energy that is placed outside the campus. And basically there the energy management has to take into consideration not only the user's comfort conditions, but also how much energy do we have available in the batteries in that container, and also of course the estimation of how much energy will be produced during that day.
Our intelligent energy management system is the first system that we know of that follows an open service-oriented architecture where multiple services can be orchestrated to create new sophisticated applications. And not only for experts such as facilities managers and energy managers, but also to the common occupant user. From the first time, we will be able to demonstrate that it is possible to create applications for a building, for an intelligent facility by reusing existing components. And this can be done also by the users themselves, and we can tap into the user's ingenuity to co-create these new applications and overcome the energy efficiency bottlenecks that we have here in the campus.
By the combination of these factors, the Tagus Park pilot project within the Smart Campus aims to develop, in fact, this new generation of intelligent energy management systems that will help us become more energy efficient, and we strongly believe that we have the conditions to achieve this within this project and obviously within all the partners that are involved in the project.
Our idea is, first of all, to save energy in our institution, but more important than this is that we strongly believe that this might be extended to the rest of the society as a whole. And we have to take into account that Portugal imports lots of energy, and we usually don't make a very efficient use of it.
This is a solution that will be truly scalable and adapted to all kinds of service buildings, and not only university campus, with the ultimate goal of fostering user behavior transformation towards a more energy efficient way of dealing and interacting with the buildings itself.
By involving users and implementing pilots in the north and south of Europe, Smart Campus aims at sharing of experiences, results, best practices on user behavior transformation, and innovating on the way citizens interact with their public buildings, increasing the citizen participation on environment sustainability under the new human smart city paradigm.